This presentation concerns black slate, transformed by a pyroplastic process named exfoliated slate or pyro-expanded slate, while material used in sculpture. It presents the results of an academic research characterized by the crossing of knowledge from the fields of geology and material science with concepts and practices of the fields of art and sculpture. Slate is a rock resulting from the action of regional low-grade metamorphism, characterized by fine granularity, high fissibility, and soft touch in black and dark gray color. The starting geological material is clay, with many organic matter and clay minerals, more precisely, hydrated phyllosilicates, that cause the fissibility gained during transformation. The black slate being investigated was supplied by an enterprise involved in quarrying and processing black slate, and whose activities are located in Campo Valongo, northwest Portugal. Submitted to a heating process similar to the ordinary ceramic process, black slate can expand 4 times its volume and becomes a distinct material in terms of mineral and chemical composition, structure, and appearance. Black slate thermal expansion is the result of gaseous formation and of the vitrification process of its mass during the thermal treatment that results in the formation of a glass that provides gas retention. In the adopted firing cycle, the thermal gradient was 100 Celsius degrees per hour, up to 300 C being reached. Temperature increase from 300 C up to 1000 C did last about 3 hours, and from 1000 C to 1240 C did last 2 hours. 2 of the most significant factors involved in the process of pyro-expansion of slate, in what concerns to slate shaping and appearance, are presented. The first one is the temperature to which slate is submitted, and it describes the way slate behaves when submitted to temperatures between 1000 C and 1240 C. We named this description free pyroplastic expansion of slate. The second one, whose description we named constrained pyroplastic expansion of slate, is about the constraints produced by interactions between different elements of slate, or between these and ceramic and iron elements. Free pyroplastic expansion of slate. Slate behavior, when submitted to high temperatures, exposes some variation, because slate does not always have the same composition or a similar structure, and, however, there is a strong degree of proximity in most results. When black slate is submitted to temperatures over 1050 C, expansion takes place and the overlapping fine structural blades, proper of this type of rock, become separated from each other, but without being individualized. It means that, in the case of a parallelepiped shape, the opposed faces, that are parallel to lamination, will not exhibit significant changes of area, whereas the 4 other faces, perpendicular to lamination, increase in area up to 4 times. After firing up to 1000 C, the color of the black slate changes from black to rose and rusty red, but the fired piece keeps its shape. Fired up to 1080 C, the black slate piece can expand 100%, or even more, depending upon how the pieces are positioned inside the kiln. If pieces lie down on a face parallel to the lamination, expansion amplitude is lower than when the black slate piece lies down on a face perpendicular to the lamination. Increasing the firing temperature, the black slate piece becomes darker and maintains the rusty red color, but gains in gloss and shows a silky sheen. On the external faces, parallel to lamination, pimples are developed and the other external surfaces becomes very textured, looking like the bark of some trees. The overlapping laminas lose their original perfect connection, whereas their hardness and mechanical resistance increase. it changes to a less dense and light material. Submitted to 1150 C, the piece texture gets thinner and dense, and the shape of the final product is quite different from the original shape. Also, the internal structure made of overlapped laminas changes to a spongy structure. The external surfaces show a more uniform gloss, reminding the gloss of leather, and its relief is accentuated. The skin shows ragged areas, with peepholes through which one can see the characteristic spongy interior mass. The most internal zone of this spongy structure exhibits black color and as far as it gets close to the surface, changes to gray and to light red very close to the surface. These color changes indicate the easy or difficulty of access of oxygen during firing. The spongy interior also differs from vitrified surface with regard to structural capacity, being the surface a lot tougher than the interior. The black slate did lose some weight, hardness, and mechanical resistance, becoming fragile and brittle, but acquires a very expressive telluric character, reflecting the intensity of the ceramic firing process. Fire up to 1150 C. The pieces of pyro-expanded black slate, in case they are put all together, become bond to each other. Hence, when they are placed inside the kiln, it's important to separate or isolate them from the kiln walls and from the kiln furniture. Fired up to 1240 C, the pervious skin is ripped apart, showing the sandy and porous texture of its internal spongy mass. The initial compact volume becomes expanded and open up its interior, but black slate recovers the hardness and mechanical resistance. The relationship between volume and weight do not substantially changes in the temperature range of 1150 C to 1240 C, but if different black slate pieces are in contact, and due to vitrification, become more firmly fixed to each other. The expansion amplitude of the black slate is primarily correlated with the specificities of the initial black slate, the firing cycle, as well as with the dimension of the tested piece. That is, factors such as mass and weight have influence in the expansion amplitude. Constrained pyroplastic expansion of slate. Expansion during the firing allows slate elements to interact between themselves in terms of a shaping process. This may happen in two different ways: assemblies and mortises. Assemblies are based on the fact that slate pieces stick together when in contact during the firing. They stick more strongly if the contact is strengthened by some kind of pressure, such as the weight of an element on the other. Slate pieces can expand and stick together in just one firing, or they can be expanded previously and be submitted to a second firing to be assembled. This latter option allows composing in a more safe way, since the second fire doesn't imply a radical change in volume or shape. Assemblies can integrate elements of other materials with good refractory characteristics, as ceramics or iron ones. They fix to the slate when brought into contact with it. The mortises of a slate piece in another one are carried out by cutting an entrance in one of the pieces, or in both. The width of the cut must be related to the thickness of the piece to be encased. In the adjacent area to the mortises, the expansion is mutually constrained, resulting in rich expressiveness. Interactions between slate elements and ceramic elements were explored, and one example is presented. Slate elements partially placed inside a ceramic container has different values of expansion. The portion placed inside the ceramic container has the size of the container interior space as limit of expansion, and the portion placed outside the ceramic container expands completely. The ceramic container and slate elements stick together. Interactions between slate elements and iron elements were also explored, and one example is presented. A wire piece, 2.5 millimeters thick, placed all around the parallelepiped slate, provides a belting effect. The expansion of the slate pressured and strained the wire, configuring in this case a mutual shaping process. The possibilities of interactions presented here are not an exhaustive survey of elementary solutions that combined make possible an increasing complexity and sophistication of pyro-expanded slate sculptural work. Pyro-expanded slate structure gets close to the structure of some pyroclastic volcanic rocks, characterized by the existence of gas pockets, fact that confers them the capacity of floating in water, as it happens with pumice. The existence of iron is fundamental for the transformation process since it conditioned the fusion temperature, liberates oxygen at 1000 C, temperature at which the glass is already formed, and also causes the color and the metallic aspect of surfaces. The technical process involved, the refractoriness being acquired, and its chemical composition, indicate that pyro-expanded slate is a ceramic material. This material shows a migrating identity, since a natural stone has changed into a ceramic material, and clarifies, in a surprising way, the relationships between stone, ceramics, and iron, in the natural geological context. This material tells us about matter in a very matteric way.